Our lesson for today will be looking at Chemistry 1502. The topic for today is introductions of ketones, which is one of the functional groups. Lesson 101, let us start. Ketones is one of the functional groups we have to discuss. Since you know the alkanes, alkynes, alcohols, aldehydes, carboxylic acids, ethers, and also the cyclose. So you should know that ketones are similar to aldehydes. They contain a carbonyl group with two organic groups attached to the carbon atom of the carbonyl group. I mean the carbonyl group, not the carbonyl. Meaning that on a compound, in order for us to identify a ketone, we should be looking at something like this. Remember aldehyde, we have, and then we have hydrogen here. So this one, it's actually like this. The oxygen double bonded to carbon can be in between two other carbons, and the general formula is CnH2nO, similar to the aldehyde. So the two functional groups they are more or less the same, but the position of the double bond to oxygen is different. That is why we say they are both belong to carbonyl group. And you should know that the ending name is O. Sometimes we'd say it's one, but we actually pronounce it as O. Let us jump and go to the first one. Now we don't have methanol like the aldehydes and the alkanes, because remember that this carbon containing a carbonyl group should be in between other carbons. So since we have only one carbon when you talk about a meth, we cannot do this. You can clearly see that we need other carbons here, and then the moment we put other carbons, it's no longer a meth, it will be a prop. So we start with a compound that has 3 carbons when you talk about ketones. So we know that we have 3 carbons, so it will be prop. As usual, I would like to say it's propan, and then you put the ending name for ketones, which is on, some say 1, then it's propanone. Then we don't have to say 3-propanone, because this is the only position the double bond to oxygen can be at. So the second one, we can just look at this, and then we put our oxygen here. So we have 1, 2, 3, 4, and count from here. We have 1, 2, 3, 4. So if you count from left to right, we can see that oxygen is on carbon number 2. Then we count from left to right, it's on carbon number 3. So it's 2 against 3. Remember that you have to always choose the lowest number. So in this case, you're going to go from left to right. So we have 4 of them, so it's butan -2 -O. You can say it's 2 butanone. Okay, let us look at this one. We count from left to right. We have 1, 2, 3, 4, 5. When you count from right to left, we have 1, 2, 3, 4, 5, 6. I actually forgot to include this one, it's 6. So you can see that we are comparing 3 against 4. Then we can see that 3 is the smallest number, and remember it will always take the priority, the oxygen double bonded to this carbon. So we're going to count from left to right. Then we can see that on carbon number 3 we have a methyl. Carbon number 5 we have 2 methyls. So let us start with the methyls. We have on carbon number 3, actually carbon number 4, counting from left to right, we have a methyl. Carbon number 5, we have another methyl. Also on carbon number 5, we have another methyl. So we know very well that for 2 it's di, for 2, tri it's 3. And then we have hexane. On carbon number 3 we have, you can see that we have 6 carbons, so it's hexane. Carbon number 3, that is where we have our carbonyl group, and then we have O since it belongs to ketones. So writing the name for this, you're going to have 4, 5, 5. Trimethyl is 1 with. Hexane is also 1 with. 3, O. Another example of a ketone is the one that involves the cyclics or the cyclose. So we'll always consider the first carbon, this one, as our first carbon. 2, 3, 4, 5, 6. We might actually take this direction, it doesn't matter, we still have the same answer. So in this case we have cyclohexane, then remember that under ketones we have O, so it's hexanone, then the name is cyclohexanone. There will be a lesson video whereby we'll be looking at about 20 IUPAC name for different structures. That is for practice question, meaning that we'll be looking at more complicated structures whereby we have more than 2 functional groups within a compound. So let us look at this one. We can see that we have a double bond and also a carbonyl group. So when it comes to priority, we are going to start counting from the carbonyl. Carbonyl should have a small number or a least number. So we're going to have 1, 2, 3, 4, 5, 6. So we can see that on carbon number 3 we have an alkene, then carbon number 1 we have a carbonyl. Then we can see that this is a cycle, so it's a cyclo. We have 6 carbons, cyclohexanone. But we should take note of the position of the double bond and also this, but it is optional because we know that it will always be on the first. So the name for this, we cannot say 3-alkene, no. We're going to start with cyclohexane. Actually it cannot be hexane because we have a double bond, so it's hex-3-ene. This represents the position of a double bond, and then we can say -1-O. Then this represents the position of our carbonyl group, or we can simply say cyclohexane, and then we put our ONE. So if it happens that we have a double bond here instead of here, then we know that this number will just change. So this represents the double bond, and then this represents the carbonyl, the position of the carbonyl group. So remember that these lesson videos, they are preparing you to understand the oxidation of alcohols, the hydroxy groups, to one of these functional groups, which are aldehydes, ketones, and carboxylic acid. So just make sure that you watch all these lesson videos, especially these three: aldehyde, ketones, and carboxylic acid, so that you can understand the oxidation well. That's it for this lesson video. This is Rahula SJ. Thank you very much.